In this video, we're going to be doing a demonstration of AI security risk assessment through scenario demonstration, and the specific scenario that we are using to understand the AI security risk assessment is the cloud and edge AI in 6G network trust infrastructures. What is the specific outcome of this demonstration and exercise? We are trying to understand, the 6G trust architecture through vulnerabilities and adversarial perceptions. Second thing that we're trying to understand in this scenario is to apply the AI risk modeling techniques to federated, distributed, and cloud-native AI systems. So this is not only specific to 6G, but it's also specific to cloud and edge in 6G. And the final research outcome, expected research outcome, is to assess limitations of conventional AI security practices in real-time, ultra-low latency environments. We don't yet have 6G. We're currently at the 5G stage, but 6G is on its way. Same like we had 2G, 3G, 4G, now we're in the 5G. 6G is on the way. We don't really have a test bed to test this. That's why this is not a penetration testing scenario. This is a red teaming scenario. And red teaming scenarios are mostly useful in cases like this when you have to really rethink. So this is one of 3 scenarios that I'm going to present, and I'm going to use whiteboards. So this is just introduction to what the scenario would include. And then I'm going to shift to my iPad, and I'm going to use the iPad whiteboard to draw the connecting points here. So the specific scenario is that we're looking at compromised trust in federated edge intelligence for 6G. And we have specific red teaming scenario. We're going to be looking at specific security risk assessment, and we're going to be covering 3 specific steps that you need to do to create, to identify the vulnerabilities and to create a defensive posture. Now, that is the introduction. I'm going to shift to the tablet, so I'm going to close this screen. And I'm just opening my tablet. This might take a couple of seconds, and you're going to see the screen share once I'm done. There we are. So now the screen share, you should be seeing the same, but with a different lens. So let me test the pencil. I'm using Apple Pen for this. Let's go with the green cover. So we have covered, we need bigger pen, maybe this one. We covered that part here, what is the specific scenario, and now we are looking at the scenario simulation. So we have a compromised trust anchor in federated edge intelligence for 6G. The 6G pilot infrastructure is based on dynamic decentralized trust models, integrating cloud-native AI services and federated edge learning agents that would depend on the key elements. And this spelling here, it's not because I use generative AI, it's just because I'm bad at spelling. Actually, the diagram is designed in using Microsoft Visio, and in the next presentation I'm going to try to check for more spelling mistakes. But why do we need to have this kind of pilot scenarios? Because we need to understand what are we actually testing. Usually when you go to a company and you say pen test, you have like, this is our network, but you have to pen test for this specific problem. That is what they allow you to pen test. This one is not in your, they're not interested in testing that. So that's why we create scenarios like this, and this could be one example that needs to be testing. 6G is one of the new technologies that is coming up, so we really need to test those new technologies before we deploy them. And how would you test this? First, you start with 3 steps. First is AI-based behavioral baselining for autonomous risk scoring. So you need to have a baseline and risk score. Otherwise, you won't be able to assess how severe some specific risk is in this 6G scenario. Then the second is to have distributed identity verification across cloud edge nodes. Why do we need to have this? because we are creating a specific cloud edge 6G scenario. The expectation here is that in the future, when you have everything is shifting to the cloud, we won't have much of, especially when you have the speed of 6G, even with 5G, it doesn't really make sense to have much of IT operational centers. Most of the IT operations will be shifted in the cloud in the next few years. Actually, more than 90% have already shifted in the cloud. Nobody stores data except some banks, for example, for security reasons, but most organizations, they store their data in the cloud because it's fairly secure. So that's why we're testing cloud edge nodes. Because the edge nodes of the cloud is where most of the risk is. Once the data is in the cloud, then the clouds are fairly secure these days. Third, we need to have trust orchestration with a trust control plane. And why do we need those? Because these edge AI agents would perform traffic anomaly detection, microsegmentation enforcement, and SLA-aware QoS optimizations. Now, let's create a specific threat scenario, and I'm going to go through the scenario, and then I will tell you the steps more specifically. So after I go through all these expectations of what do we need to do, I will come back. I'll change the pencil to red, for example, and I'll come back to tell you the specific problems. So the red teaming, this is an intelligent scenario. So then I have three scenarios. This one is intelligent scenario. The next one is going to be on something else, red teaming, but not intelligent. So in this one, we are looking at adversarial actors that have executed poisoning attacks during the initial federated training on edge anomaly detection and exfiltrated the weights of trust scores with side channel leakage in a containerized microservice hosted on the edge. So federated training, we're gonna cover federated learning in other scenarios, but federated learning is when you don't want the federated learning and secure multi-party computation. Are a few techniques that you can make the model transparent and still have the privacy of the end user inside. So if you have, let's say, user 1, 2, 3, 4, 5, and you need all that data to be shared with the cloud server with the, let's say, 6G connectivity, so ultra speed, then the federated learning, it refers to how much of your data would be shared in the cloud. And then you set up data privacy. So the more private is the data, then you add more noise, but then it's less useful. So that is, federated learning is one of two main techniques that is going to be used in the future. That's one of the most promising techniques, and that's why it's included in the scenario. So how would you perform security risk assessment on cloud edge in 6G network trust infrastructures? Let's start with the steps. Step number 1 is threat modeling. You need to assess the risk across the following dimensions. First, you need to identify the primary attack vectors that are targeting the AI pipeline and trust established mechanisms. Second is you need to describe the adversary goals, for example, model skewing, trust score manipulation, cloud edge, node impersonalization. And third step is you need to map the threat actors. So the insider threat, the compromised third-party inference API, state-sponsored actor exploiting 6G dependencies. So that is the first step of the threat modeling across the dimensions. Second step is risk analysis matrices. And so this risk analysis would usually contain 2 or 3 axes. So first axe would be the attack surface. So here you have, we already said what is federated learning. So you will have federated learning, and you're looking at vulnerabilities in federated learning, because nothing is perfect. Everything has vulnerabilities. Then you're looking at the container orchestration, the real-time edge inference, and cloud control APIs. I'm gonna come back to that, but let's look at the second vector in this matrix. You need to also look at the impact severity. What is the trust revocation? AI hallucinations at the edge, that could be problematic, and we need to consider that. false trust propagation across the mesh. That is another problem. And you also, at that step, the second step, you need to include data integrity risks, model poisoning risk, trust score misalignment, compromise of decentralized identity anchors. Decentralization adds security because there is no central point. So if you have one central point, you drop a bomb on it and that's gone. But if you have decentralized data points, some of them, let's say this one we can refer to the Bitcoin, which is a decentralized system with many nodes. So if you kill some of those nodes, as long as one node is operational, it's going to continue to work. And that one node could be hidden in the basement in Turkmenistan, or it could be in a plain sight in your office, just under the desk somewhere running the Bitcoin node, or in a data center. So it's difficult to kill decentralized systems. Centralized systems are easier to destroy with, let's say, physical attacks, but decentralized systems are subject to more systemic risk when you have compromise of identity anchors. So this is where different types of risks emerge, depending if it's a centralized or decentralized. But decentralization is expected to be part of the future networks because it's difficult to destroy. And if that still doesn't make sense, if you're still not convinced that decentralization is the way forward, well, think about red teaming comes from military doctrine. It started for wargaming, and then it was adopted for various different scenarios testing. And one recent military embarrassment was the Russian colonies, how the centralized systems of colonies going forward, how they got blasted on a few weak points and they got stopped. And now everything is moving towards drone warfare, which is decentralized. You kill one drone, there's like loads of other drones flying. So decentralization is seen as the way forward, and automation is also seen as a way forward. And if you watch the recent news of how Ukraine destroyed some really expensive bombers in Russia using AI drones, then it becomes clear why this decentralization and automation is where the technology is heading forward. And that's why those technologies are included in this scenario. And the third step is the defensive posture review and the mitigation techniques that you would recommend as a part of your red teaming. So the first one, in order to be able to populate these review reports, you need to conduct adversarial training. So can we stimulate poisoning attempts to harden the federated models? Differential privacy, how do we prevent data leakage from gradient sharing? Runtime attestation, how do you validate AI models integrity during live inference at the edge? And zero trust AI, is every inference call logged, verifiable and explainable? So that is the scenario that I've prepared, and I've explained why each one in specific point is listed there, going from explanations about decentralization, about the 6G and the cloud and trusted control environment and edge devices. Now, let's look at this from a slightly more, how to say, generic explanation. Let's say we look at this from a training perspective. What do we get from this exercise here? Well, we're testing trust degradation in model integrity in distributed systems specific to 6G edge cloud AI architectures. And these kind of exercises, they set the foundation for understanding how distributed AI models and trust mechanisms behave under adversarial conditions in 6G systems, which they don't exist yet. So we know how those conditions are set, even though the 6G doesn't exist yet. And if we look at just an overview of the scenario simulation here, let's talk through how this scenario demonstration explains the fragility of decentralized AI systems in trust systems in 6G networks, because 6G infrastructure leans on distributed and federated AI systems. That's where 6G is based. So the attack surface expands not just in scale, but the complexity of those new technologies that they're coming up. And the system architecture in this scenario, the 6G pilot deployment, for example, is running federated AI agents at the edge. So those agents are responsible for traffic anomaly detection, microsegmentation, enforcement, QoS optimization. Those are the specific things that we have mentioned here. The trust fabric in this ecosystem is supported by distributed identity verification between edge and the cloud. So you have edge device here. This could be an IoT device or a gateway, and then you have the cloud. So we're looking at the connectivity from that point to this point. So that is the section that we're looking. And for that, we need AI trust control plane to coordinate decisions, and we need AI-based behavioral baselining for scoring node and model integrity. And those layers are designed for real-time context-aware decisions. But they rely entirely on the accuracy and the integrity of the AI models and the telemetry exchange between the nodes. So if you have multiple different nodes, this scenario is based on understanding that it's not only the risk in the cloud, but there's also a risk in between nodes. So those nodes communicate somehow, and then they need to call home. This is where the AI is based. We're not going to have AI on IoT devices. Well, we do have some AI on low memory devices. We call that AI on a diet, but it has limited functionality. Most of the time, those nodes would communicate with 6G ultra speed network to the cloud, where the AI analysis would be happening. And here, if we're looking at the red teaming scenario specifically now, in this simulated red team campaign, adversarial actors compromise the systems during the initial federated training of the edge-based anomaly. So here, in this scenario, we have two attack vectors. Model poisoning, when they inject skewed gradients into the shared federation, and weight exfiltration, when they extract trust score weights through side channel leakage from a container running at the edge, for example. So what is the attacker goal? It's to subvert the entire trust systems so that malicious edge agents are misclassified as trustworthy and real anomalies are ignored. That is the purpose of the scenario that we have created. And moving on to the threat modeling here. So we have explained the scenario, and we're moving to the threat modeling, what's happening in the threat modeling, and why do we need to have those specific elements in the threat modeling. We start in this exercise with mapping the threat models across those three axes. So that's 1, 2, 3. And first we start with attack vectors. Poisoned updates in federated training, container escape and side channel monitoring, API spoofing from compromised cloud control services. Those are in the first category. The second category would be adversary goals. So, and here we are, the adversary goals, just to make sure we are following. In this section with the adversary goals, we're looking at manipulations of the trust scores in the TCP. We are also looking at bypass anomaly detection using poisoned inferences. And the third final here in that second category is we're looking at impersonating cloud and edge nodes to propagate false trust signals. Now, looking at the threat actors, so here we are, the threat actors in the third point. We're specifically focusing on identifying malicious insiders in third-party vendors, and we're looking at compromised inference as a service endpoint. And finally, it's the nation-state adversaries targeting telecom infrastructure. So who could be a nation-state adversary targeting at this stage? This is a question for you to think, who could possibly have the power to attack this? Well, it's going to be the Lazarus Group, obviously. They are the leading actors in this space. So first nation state is going to be the Lazarus group. There are many other nation state, but in the interest of diplomacy, let's leave that one aside. We can all talk bad things about the Lazarus group, but let's leave other nation state groups out of this training material. But you can easily find nation state sponsored cyber criminals. Now looking at the second step here, which is the risk analysis matrix. Participants of this kind of exercises, usually you need to have people in the experts in this area, so they need to be able to populate AI risk matrix within those dimensions that they're included here. So how would you make sure that people can populate? Well, you have to give them a framework of things that they will need to do. So first is, let's look at the attack surface. The attack surface includes federated learning logic, container orchestration, runtime, real-time edge inference layer, cloud control APIs. So that is going to be the attack surface. You start from those 4 points. Then when you look at the impact severity, here you have completely different 4 points that you would include in the scenario building. You're looking at trust revocation cascade, AI hallucinations at the edge, false positives or unprecedented, undetected intrusions. You're also looking at inner node poisoning with corrupted trust propagation. And finally, this is something that I need to add here. I've just realized that I mentioned 3 axes, but actually I have 2. So I need to add the third axe over there. The third axe would be visibility and detection difficulty. So here you're looking at edge leakage, often remains unmonitored. Then federated updates are usually opaque by default. Runtime scoring systems are often non-verifiable. And now moving to the step number 3 of this exercise, the defensive posture review. Here you need to ask, so whoever are the participants in your group that are running this red teaming scenario, you need to ask them to stress test the defense stack and to stimulate. But to stimulate the attack, you need to give them a strategy of how. You need to set the parameters of that testing. So first is the adversarial training that we discussed. The question is, can we stimulate realistic poisoning attempts in federated training cycles to proactively harden the modules? Can we do that? And if we can, then the second is differential privacy. How can we prevent the attackers from reverse engineering model weights with leaked gradients? So that's the second thing. And third would be runtime attestation. Can we continuously validate the AI models at the edge that they haven't been tampered with post-deployment, for example? Final thing of this framework that you're setting up for the testing is the zero trust AI. In every model, there's an inference variable, and this is attributable with auditable logs. So what are the takeaways from this exercise? Let's look at the holistic image, and just reminder, I do have another scenario which I'm gonna record the video, and there's more. There's actually one more over here, so there's 3 scenarios. This is just one. This is the specific to cloud and edge in 6G network trust infrastructures. We're gonna be looking at different aspects. So what is the takeaway from this scenario? If you run a red teaming scenario like this, we can uncover how quickly a poison model in a federated edge AI system can undermine the trust across a 6G mesh. And the key insights here include the collapse of trust scoring through telemetry biasing, for example. Second research takeaway is the blind spots in containerized edge inference environments. And third is the need for runtime model verification across all inference points. So at the runtime, you need to test the model at all those points before you go live. And by now, you should be able to understand the model threat pathways that exploit decentralized trust systems in 6G. You should be able to identify the risk in federated and distributed AI training environments. You should be able to evaluate the real-time defenses, including runtime attestation and mode validation. And you need to be able to recognize why zero trust in the AI system is not optional at the edge, it's compulsory. So that concludes this part of the scenario. I'm gonna stop mirroring here. Let's see if I can bring back the camera. There we are. So the purpose of red teaming exercises, as you can see, is to bring some novelty to analysis. So usually you have, let's say, consultants that they analyze whatever you tell them to analyze, and they do that based on their expert opinion. You have consultants that they've been working in industry for many years, and they know how to fix solutions to problems that they exist. You have problem in your IT infrastructure, in your cloud infrastructure, in your 5G infrastructure. They know how to fix it. They'll come and they'll fix it just on the top of their mind. They know how to do it. But how about when you have infrastructure that doesn't exist yet, the 6G infrastructure? How do you pen test that? Well, you can't pen test it. That's where red teaming comes into play. You create scenarios, but those scenarios like this one, when you create, where do they come from? Does it come from a consultant just, coming up with ideas? No, they don't. So those boxes that they're featured in these scenarios, they come from existing literature. And there's loads and loads and loads of studies published in top-ranked journals and conferences like Nature Scientific or AI leading journals and conferences, where people are trying to detect specific vulnerabilities. And the scenario that you have here, it's a combination of multiple weaknesses that they have been identified and collected in the actual paper on this topic. I'm going to be including the references, so you would be able to detect how each scenario, each point in that scenario, and why is it included, because author X presented on conference in somewhere that scenario is possible and demonstrated through some kind of a testing. But this is the end of the first scenario, and I will switch off now and I'll start to prepare and I'll start recording the second scenario.